Okay, so this is the seventh lesson in the algebra series. So today we will discuss past paper problems from 2009 to 2014. Right. So this is the factor and remainder theorem question from 2009 A level. Right. So first part is what? Proving the remainder theorem. Given a polynomial fx, if you divide it by x minus alpha, remainder is given by f alpha. So we have done this several times. We'll do it quickly. So you use what? Division algorithm form. So we have the function fx. So when we divide it by x minus alpha, you get a quotient. And because the divisor is degree 1 or linear, remainder is a constant r. Now substitute x equals alpha into 1 and we have the result. So f alpha, q alpha, alpha minus alpha plus r. So what does this imply? This imply remainder r is equal to f alpha. So first part is done. Right, now let's see. They have given that when the polynomial fx is divided by this one, this divisor, a cubic divisor, where alpha, beta, gamma are unequal real numbers. Unequal real numbers. The remainder takes this form. So it's a what? We have a cubic divisor, so the remainder is a degree less, so it's a quadratic, no? So that type, correct. So we have to find a, b, c in terms of these alpha, beta, gamma, f alpha, f beta, and f gamma. Right. So let's set up the division algorithm form for this. So f of x, some quotient q of x, the divisor x minus alpha, x minus beta times x minus gamma plus the remainder. Remainder is what? A x minus beta, x minus gamma plus b times x minus alpha, x minus gamma plus c x minus alpha, x minus beta. So let's take this as equation 2. Right. So we just have to substitute what? X equals alpha, x equals beta, and x equals gamma and create 3 equations to get the 3 unknowns a, b, and c. Right. So let's first do x equals alpha. Sub x equals alpha into equation 2. What happens? F alpha on this side, alpha minus alpha becomes 0. So the first term becomes 0. Then we have, and then look at this one. The third term, again alpha minus alpha becomes 0. Again the fourth term, alpha minus alpha becomes 0. So only this second term is left. So what do you get? F alpha equals a alpha minus beta alpha minus gamma. Then from that you can find a. So we have an expression for a. A is what? F alpha alpha minus beta alpha minus gamma. Right, now you can do x equals beta. Sub x equals beta into equation 2. So you will get what? F beta equals to what? So when I substitute x equals beta, first term becomes 0 because beta minus beta. Second term also becomes 0 because beta minus beta is 0. And the last term, beta minus beta becomes 0. Right, then only this third term is left. So you get beta minus alpha, beta minus gamma. So then from that we have B is f of beta, beta minus alpha, beta minus gamma. So we can actually guess the C value. It's the same pattern. No? So what's C going to be? C is going to be f of gamma, gamma minus alpha, gamma minus beta. You can see that from subbing x equals gamma also into 3 into 2. So you will get what? F of gamma equals C times what? First term becomes 0, second term becomes 0, third term becomes 0, only C is left. So you get C times gamma minus alpha, gamma minus beta. Right. So that part is done. A, B, and C were found. Right. So now the last part. Find the value of constant k for which the remainder, k for which the remainder, when this is divided by this cubic divisor, contains no term in x. So the remainder will not have x in it. So there will be no x term in the remainder. So look at the divisor. Divisor is of this form, no? The form we just did. So the remainder would have this form, right? For divisor of this type, remainder has that form. So let's look at the remainder first. Let's write it out. The remainder r of x is what? A x minus beta x minus gamma b x minus alpha x minus gamma plus c x minus alpha x minus beta, right? Beta gamma, alpha gamma, and alpha beta, right? So now for this remainder, the x term is not there according to the question. When x term is not there, we want to find this k value, right? So let's expand this quickly. All of them have the same form, no? So a x squared what? Minus beta plus gamma x plus beta gamma b, same form, no? So minus alpha plus gamma x alpha gamma plus c x squared minus alpha plus beta x x plus alpha beta, right? So then let's look at the x term. X term in the remainder is what? Let's look at the coefficients of that. So x term, these three. So you will get minus a beta plus gamma minus b alpha plus gamma minus c alpha plus beta. Now according to the given data, we want to find k when this is 0. We want this coefficient to be 0, right? Okay, so we know that, and we have a, b, and c. A, b, and c are these. And now for the given divisor, let's figure out what alpha, beta, gamma I is going to be. So we have x plus 1, x minus 1, x minus 2. So we'll write it in the correct form so that we can quickly identify alpha, beta, gamma. So from this one, alpha is minus 1, From this one, beta is 1. From this one, gamma is 2. Right. So now let's substitute those values here and try to find the k value. So we have minus a beta plus gamma, beta plus gamma minus b alpha plus gamma. Alpha is minus 1, gamma is 2, minus c. What do we have? Minus c alpha plus beta. What is alpha? Alpha is minus 1, beta is plus 1. So what do we have now? Minus 3a minus b is equal to 0. Right. Now let's substitute a and b. These are a and b. And we have to substitute alpha and beta values too. So first just let's substitute a minus 3 f of alpha over alpha minus beta, alpha minus gamma, minus b f of beta, beta minus alpha, beta minus gamma equal to 0. Right. So now let's substitute the values. Alpha minus 1, beta 1 and gamma 2. So we have from here minus 3 f of minus 1 alpha minus beta minus 1 minus 1 minus 1 minus 2 minus f of 1 1 minus minus 1 1 minus 2 equal to 0. Right. Now simplify that, you get what? Minus 3 f of minus 1 minus 3 f of minus 1 minus 2 plus minus 2 times minus 3, so plus 6 minus f of 1 1 and minus 1 1 minus minus 1 become plus 1, so 2 times minus 1, so minus 2, and this minus and that minus cancel, so this becomes plus 2 equal to 0. Again simplify, so we have minus f of minus 1 2 plus f of 1 over 2 equals 0. Or get rid of the minus, so get rid of the 2, so minus f of 1 plus f of 1 is equal to 0. Right. Now let's go back to the function. So what is the function? X to the 5 minus kx. So that is our function, x to the 5 minus kx. Let me write that function, x to the 5 minus kx. Right. So now we want to find the k value now. So f to the minus 1 is what? Minus 1 plus kx plus f of 1 is what? 1 minus k. So not kx, k equal to 0. Now simplify. 1 minus k plus 1 minus k okay. So then, right, we have the k value now. You have 2k equals 2 or k equals 1. Right. So right, so that's the final part of 2009 A level question. Right. So we are done with that one. So next let's look at 2010 A level. So A, B, C and M are constant such that AB plus C equals 0, and this expression is also equal to 0. Okay, we have to prove this, right? So I'm going to start with the left hand side and expand it and prove the other side. So we have this plus this. So let's expand. So I will get y squared c xy plus b xy plus b c x squared. Right. Then again expand, you will get what? Y cube c xy squared b xy squared bc x squared y a xy squared a x squared y, sorry, ac x squared y ac x squared y ab x squared y abc x cube. Right, now we have to simplify it into this form. So abc x cube we need, so we already have that. Right, rest I have to simplify using these two expressions. Right, so let's keep this that we need and let's simplify the rest. So we have y cube, we have, okay, these two and this, right? The xy squared terms, we can combine the xy squared terms. What do we get? We get a plus b plus c xy squared. So those three are done. So this is done, this is done, this is done, this is done. Then the last three. So last three you can write what? AB plus BC plus AC times x squared y plus ABC x cube. Okay, now we use these two expressions. What is A plus B plus C? That is equal to 0. So this is equal to 0. Then from the second given expression, what is AB plus BC plus CA? That is going to be equal to minus 3M. So this is going to be equal to minus 3M from the second expression given to you. Right, now using that we will simplify this. So we'll get y cube, second term is 0. This term becomes minus 3m x squared y plus abc x cube. Right, now look at the thing we want to prove and simplify. So right, we need to take a y out, then y squared is there and 3m x squared is there. Right, okay, there's the expression we needed. Right, so first part is done. Right, then what are they saying? Okay, if y is equal to x squared m, if y is equal to x squared m, then show this. Right, so we now have shown this. No, let's say this is equation 1. Now substitute what? Sub y equals x squared m, x squared plus m into 1. sub y equals x squared plus m into 1 on both sides. So you will get what? X squared plus ax plus m, x squared plus bx plus m, x squared plus cx plus m on the left hand side. Then on the right hand side substitute here. So we'll get what? Y is x squared plus m, then y squared. So x squared plus m whole thing squared minus 3mx squared plus abc x cube plus abc x cube. So left hand side we don't need to simplify, that is what we want. Right hand side, let's look at the expression and simplify. So we need to simplify it to this. So abc x cube we need, no, we already have that. So let's keep it here and don't touch it and simplify the rest, right? So let's work on the inside part first, this part. X squared plus m, expand, you get x to the 4, 2m x squared plus m squared minus 3m x squared plus abc x cube, right? So now let's simplify this. We get it x squared plus m, x to the 4, 2mx squared, 3 minus 3mx squared becomes minus mx squared plus m squared plus abc x cube. Right, now again get rid of brackets, you get x to the 6 minus m x to the 4 plus m squared x squared plus m x to the 4 minus m squared x squared plus m cube abc x cube. Now cancel what you can cancel and you should get the required result. This one and this one cancels, this one and this one cancels, and now we have the required result. X to the 6 plus abc x cube plus m cube, right? Yes, that is what we need. So that part is also done, right? So now what are they saying? Right, if g of x is this, it has factors given like this, find the values of a and b, right? So now using the result given to us, we can do this now. So let's see, right? So g of x is what? G of x is x to the 6 plus 16 x cube plus 64. So then that means what? We'll compare it with this. ABC is 16. ABC is 16 and m cube is 64. M cube is 64. So that means m is 4. Right. Yes, that means m is 4. Right. And we have been given the factors. So we need to find a and b. M is now found. And c we know. C is what? C is minus 2. So c is minus 2 from this factor. So we know c is minus 2. So that means ab is minus 8, right? AB has to be minus 8. AB has to be minus 8. We now have M. Now we have to find what is A and B. We can use these results also, right? AB is minus 8 and A plus B plus C is what? A plus B plus C is 0. That gives you, we know C is minus 2. So A plus B has to be what? A plus B has to be 2, right? So we'll use that. A plus B plus C is 0. That means A plus B is equal to 2. Right. So then A is equal to 2 minus B. So substitute here, you get 2 minus B times B minus 8. So that will give you minus B squared plus 2B equals minus 8. So B squared minus 2B minus 8 is equal to 0. So that will give you what? B minus 4 and plus 2. B minus 4 and plus 2 equals 0. So that means B can be 4 or B can be minus 2. When B is 4, A is what? A is minus 2. When B is minus 2, A is 4. Right. So we have two pairs of values for A and B, and M is 4. So we found those. Right. Now let's see. Now what? Show that gx is non-negative for all x. Right. So let's use the values we have. X squared. What is gx? We'll use the factored form. X squared minus 2x plus 4. X squared. A and B can be what? 4 and minus 2. No? So you get x squared plus 2x plus 4 no minus 2 no minus 2. So minus 2, and here you get x squared plus 4x plus 4. So then what is the expression we have? X squared minus 2x plus 4 whole thing squared, and this is a perfect square. No? What is that? X plus 2 whole thing square. So square times square is always greater than or equal to 0. So gx has to be what? Positive or equal to 0. So that is right. So that means non-negative. Find the roots of the equation gx equals 0. Find the roots. Right. So then let's find the roots. So we have the factored form. So what are the roots of this? X equals minus 2. Then this one. X squared minus 2x plus 4. Use the quadratic formula. What do you get? X minus minus 2 plus or minus minus 2 squared minus 4. A is 4. No, A is 1. C is 4 over 2. So simplify. X equals plus 2 plus or minus 4 minus 16. So minus 12 over 2. So this becomes 2 plus or minus 2 root 3i over 2. So x equals 1 plus or minus root 3i. So roots are what? Roots are x equals minus 2, x equals 1 plus root 3i, and x equals 1 minus root 3i, right? So these are complex numbers. We will discuss them later on. So there's 3 roots here. 2 of them are complex, 1 is real, right? We'll When we do the complex number series, we'll discuss how to find these, right? Okay, so that question is done, right? So then we'll do 2011 A-level question, right? So what do we have? Given this cubic function, we have to show that this is a factor of fx. So let's use factor theorem. X minus a minus b. So x has to be a plus b. So we have to substitute this. So we have to show f of a plus b is equal to 0. Then by factor theorem, x minus a minus b is a factor of the function fx. So substitute a plus b for x. Let's see what we get. Right, now just expand the brackets and simplify, and you should get 0. A cube 3a squared b 3ab squared minus 3a squared b minus 3ab squared minus a cube minus b cube. So you a cube minus a cube cancel. I'm missing a term here. No? Yes, plus b cube. So plus b cube minus b cube cancels. 3a squared b minus 3a squared b cancel. This and this cancel. So 0. That means what? That means f of a plus b equals 0. So by factor theorem, x minus a minus b is a factor of f of x, right? So that part is done. Find the other factor fx in quadratic form. Find the other factor fx in quadratic form, right? Okay, so let's see how to do that one. Right, we'll do long division. X minus a plus b, x cube 0 x squared minus 3abx minus a cube plus b cube, right? So x squared, so I will get x cube minus a plus b x squared. Then this becomes what? A plus b x squared minus 3abx minus a cube plus b cube, right? Then I have a plus b x, right? So then I will get a plus b x squared minus a plus b squared x. Right, now these two cancel. This will give me what? A plus b squared minus 3ab x minus a cube plus b cube. Right, so then this will become what? A plus b a plus b what? A plus b squared minus 3ab. Right, so we will get a plus b squared minus 3ab, and obviously this is a factor now, so this will cancel out. So I'm going to not do the calculation separately, it's going to cancel out. So this is the quadratic we are looking for. Right, so then let's see. So that is the other factor. Right, so then we have found the other factor of fx. So fx has that factor. So let's write the factored form of fx. F of x is equal to x minus this x squared a plus bx, and that a plus bx plus a plus b squared minus 3ab. Right, so that part is done. Now let's see what to do. Hence or otherwise show that a and b are distinct. Hence or otherwise show that a and b are distinct. Then f of x equals 0 has only one real root. Right, so let's see how to do that. So a and b are distinct. What happens? If a and b are equal, what happens? And so otherwise show that a and b are distinct. Right. If a and show that if a and b are no, not we. If a and b are distinct, then only one root. Okay, right. Okay. So if a and b are distinct, we have to show that fx equals 0 has only one real root. Okay, right. So we assume, so we know a and b are distinct. Okay, a and b are distinct. A is not equal to b, right? So then we have to show this has only one real root. So let's find the discriminant of the quadratic part. So that is going to be what? A plus b squared minus 4 times 1. C is what? A plus b squared minus 3ab, right? So this turns into a plus b squared minus 4a plus b squared plus 12ab, right? So then this turns into minus 3a plus b squared plus 12ab, and that turns into, take the minus 3 out, a plus b squared minus 4ab, so that turns into minus 3 a plus b, no, yeah, so that just turns into a minus b squared. Why? If you expand this, a squared plus 2ab plus b squared minus 4ab turns into a squared minus 2ab plus b squared, which turns into a minus b squared, right? So it is given what? A and b are distinct. So this is never 0, no? Never 0, not equal to 0. That means the square part is always positive, and because of the negative sign, this is always negative. That means no real solutions for the quadratic part. Only real solution comes from where? From x minus a minus b factor. So only one real solution, which is what? Which is x equals a plus b. Right. So we have shown that if a and b are distinct, only one real solution. Right. Then what's the next part? Deduce that has only one real root and find it. Okay. So this is just applying what we just proved. So x cube minus 9x minus 12. So let's find a and b. It has this form. No? If a and b are distinct, we are done. Has only one real root and we can find it. So a minus, sorry, 3ab is equal to 9, right? So just compare them. We have x cube minus 3ab x minus a cube b cube minus a cube b cube. Compare it with what is given to us, x squared x cube minus 9x minus 12. So then a 3ab equals 9. So that gives ab is equal to 3, and that is 1. And the other one is a cube plus b cube has to be 12. So let me use from 1, I can get what? A equals 3 over b. So then I can substitute that into the second one. So I get 3 over b, 3 over b cube plus b cube equal to 12. So 27 b cube plus b cube over 12, then 12 b cube equals b cube, no, b6 plus 27. So this has quadratic form, no? Let m equals b cube. So then we have m squared plus 27 equal 12m, or m squared minus 12m plus 27 equal to 0. So m minus 9, m minus 3 equals 0. So m equals 3 or m equals 9, right? M equals 3 or m equals 9. Yes, so that means b cube equals 3 or b cube equals 9. Then a cube equals 9 from here, and this one a cube equals 3. So the solutions are what? 1/3, 9 1/3, 9 1/3, 3 1/3. Right. So then the factor is what? From the previous one, a plus b. So answer is 3 1/3, 3 to the 1/3 plus 9 to the 1/3. Because a and b are distinct, no? A and b are distinct, therefore only one real root according to the previous result. Right. So then we are done with this question. Number 7, number 2011 question. Right. So now let's look at 2012 A level question. Right. So what is given here? A quartic function is given. Using remainder theorem repeatedly show that x plus 1 squared is a factor of gx. Right. So first let's substitute 1, g of 1, and see what happens. 1 plus 4 plus 7, sorry, not 1. We want to show x plus 1 is a factor. Sorry, x plus 1 squared is a factor. So that means we have to substitute minus 1 first. So first let's show x plus 1 is a factor of gx by substituting minus 1. So minus 1 to the 4, 4 minus 1 cube plus 7 minus 1 squared, 6 minus 1 plus 2. So 1 minus 4, 7 minus 6 plus 2. So minus 10 plus 10, so 0, right? So that means x plus 1 is a factor of gx. X plus 1 is a factor of gx. So then we can write g of x using division algorithm form. Quotient x plus 1 plus no remainder, no remainder. So we have that no remainder. Then q of x is what? Going to be a cubic. So let me divide q of x by what? How to do that? Let's do this by doing what? Uh, q of x. When we divide q of x by x plus 1, what should we get? You will get s of x. That's the quotient of that x plus 1, and the remainder has to be constant, that right. So now let me substitute second equation into 2, sub 2 into 1. So we'll get g of x in this form now. S of x, x plus 1 plus r whole thing multiplied by x plus 1. So g of x, s of x, x plus 1 squared plus r times x plus 1. Right. Okay. Now how to get this? We can do what? We can differentiate g of x. Then we want to find r. No? So let me differentiate third equation. So I'll get g dash x equals what? S of x 2 x plus 1 plus s dash x plus 1 square plus r, right? And here also let me find g dash x for the given function. 4x cubed plus 12x squared plus 14x plus 6. Right. So now what is this one? This one, let's take it as 4. Objective is to show that r is 0, right? So substitute sub x equals minus 1 into 4. What happens? G dash minus 1. This term becomes 0. This term becomes 0. We have r. Then what is g dash minus 1? So r is equal to g dash minus 1. 4 minus 1 plus 12 minus 14 plus 6. So what do we get? Minus 18 plus 18, 0. Right. So remainder is 0. No? So that means what? Then for third equation becomes what? G of x. Because remainder is 0, we know g of x can be written as what? S of x, x plus 1 squared. That means what? X plus 1 squared is a factor of g of x, right? So that part is done. Now express g of x in the form x minus a squared x squared plus bx plus c, where a, b and c are constants to be determined, right? Okay, so We are going to do what? We can do, I'm going to do long division. That's easy, no? I can take this as my divisor. Expand this, so x plus 1 squared is what? X squared plus 2x plus 1. Right. Then let's do long division using that. X squared plus 2x plus 1, x to the 4, 4x cubed plus 7x squared, 6x plus 2. Right. So x squared, x to the 4, 2x cubed plus x squared, x to the 4 cancel, you get 2x cubed plus 6x squared plus 6x plus 2. Then you get plus 2x, 2x cubed plus 4x squared plus 2x. So then 2x cubed cancel, 2x squared plus 4x plus 2. So you get 2, 2x squared plus 4x plus 2, 0. Right. So then we have found the gx in factored form. X plus 1 squared, x squared plus 2x plus 2. So a is what? A is plus 1. No, a is minus 1. According to this, we want to write it in what form? X minus a squared plus squared times x squared plus bx plus c. Right. So then in that form, it's just going to be x minus minus 1 squared, x squared plus 2x plus 2. So a is minus 1, b is 2, c is 2. Right. Then deduce g of x is greater than or equal for all real values of x. Right. So we have to show this is greater than or equal. X plus 1 squared. Just do what? For this part, you just complete the square and you can get the answer. X plus 1 squared plus 1. So this is greater than or equal to 0. This is greater than 0. So the total has to be greater than or equal to 0. So g of x is greater than or equal to 0. So that is the last part of 2012 A level question. Right. Then let's look at 2013 A level question. Right. What do we have? A cubic polynomial is given, and x minus 1 is a factor of fx, and the remainder of when fx is divided by x minus 4 is minus 6. Okay. So just a simple application of factor theorem and remainder theorem. So we are given f of 1 is 0, and using that we can create one equation. So you get a plus b minus 11 plus 6 equal to 0, or a plus b equal to 5. Then using the remainder theorem, when fx is divided by x minus 4, remainder is minus 6. So that means f of 4 is minus 6. So using that we get a 4 cube plus b 4 squared minus 11 times 4 plus 6 equals to minus 6. So simplify 64a, 16a minus 44 plus 6 minus 30, minus 44 minus 38 goes to that side, becomes plus 32. So you can divide by 16. So 4a plus b equal to 2. Right. So then simultaneous equations. 2 minus 1, 3a equals minus 3. So that means a equals minus 1, Then from 1, minus 1 plus b equals 5. So b equals 6, right? So we found a and b, right? And we have to find the other two linear factors. So let's write down f of x first. A is minus 1, so minus x cubed plus 6x squared minus 11x plus 6. So then we already know one factor, which is x minus 1. X minus 1 we know is a factor. So take x minus 1. Then you can do either long division or what? Observation. I'm going to do it by observation. Minus x squared. So I get minus x cubed, and I need plus 6 as the constant. So I have to have minus 6. So let's see. I get minus x cubed plus x squared. I need 6x squared. So I need to have plus 5x here. Then we are done. So then let's find the other two linear factors. Take a minus out. So minus x minus 1. You have x squared minus 5x plus 6. So factor the quadratic, you will get what? X minus 2, x minus 3. So those are the three linear factors of this cubic polynomial. Right. So that is 2013 A-level question. Compared to the other years, this is an easy question. Just a simple application of factor and remainder theorem. Right. Then let's look at 2014 A-level question. So in this one, A belongs to R. Again, a cubic polynomial is given, and 3x minus 1 is a factor of fx. So, okay, this is similar to 2013 A level, no? So let's find A using the factor theorem. So we know 3x minus 1 is 0. That means x equals 1/3. So f of 1/3 is going to be 0 because 3x minus 1 is a factor. So then substitute that and simplify to find A. So we get 1 over 9 plus 5 over 9 plus a over 3 minus 1 equal to 0. 6 over 9, that becomes 2 over 3 plus a over 3 minus 1. Then a over equal to 0. A over 3 minus 1 over 3. So that means a equals 1. Right. So we found a value. So then f of x is what? 3x cubed plus 5x squared plus x minus 1. Right. Okay. Express f of x in the following form. Right. So we know one factor now. So 3x minus 1. So by observation, let's create the other quadratic first. So you get x squared. I want minus 1. So then I need plus 1 here. Then let's look at, I get 3x cubed minus x squared. I want 5x squared. So I need what? 3x cubed minus x squared. I need 5x squared. So I need plus 3x cubed. I need plus 6x squared. No, so plus 2x, right? So then I get the correct form now. 3x cubed minus x squared 6x squared, you get 5x squared, then minus 2x plus 3x gives you x, right? So that is the quadratic factor. Then this is a perfect square, no? X plus 1 square. So then we get 3x minus 1, x plus 1 square. So k is equal to 1. Right. So after that, what? By writing 3x minus 1 in the above expression in the form, that form. So you need to write it in this form. So let's try to write it in that form. I need to write 3x plus 1. No, I need to write 3x minus 1. 3x minus 1 as b x plus 1 plus c. b x plus 1 plus c. Right. So this is comparing two polynomials. So equating coefficients. So equate x coefficients. So you get 3 equals b. Then equate the constant terms. So minus 1 equals b plus c. So then minus 1, 3 plus c. So c is equal to minus 4. Right. So then 3x minus 1 can be written as 3x plus 1 minus 4. Right. Okay. We are done that. Now what? Now find what? Okay. Now find the remainder when f of x is divided by x plus 1 cube. Right. So now we can write f of x as what? F of x is what? 3x minus 1 x plus 1 cube, x plus 1 square. Now let's write it in this form. 3x minus 1, let's write it in that form. So you get 3 times x plus 1 minus 4 times x plus 1 square. Now get rid of brackets. You get f of x 3 times x plus 1 square cube minus 4 times x plus 1 square, right? Minus x plus 1 square, right? Right. So then we want to divide by what? Divide fx by x plus 1 cube. So what do you get? 3 minus 4x plus 1 square over x plus 1 cube. So then the remainder is what? From the division algorithm, r of x is minus 4 x plus 1 whole thing square. This is the quotient. This is the remainder over divisor. Or you can get it from here also. Quotient is 3, divisor is x plus 1 cube. Then the remainder is this part, minus 4 x plus 1 square, right? So that is the 2014 A-level question, right? Okay, in the next video we'll discuss questions from 2015 to 2019.